This video is on lesson 4, conservation of mass. This lesson is on unit 4. This video is on lesson 4, conservation of mass. Everything in this video should be review, so I'm not going to put practice problems at the very end, but you're going to need to know this, or at least recall this, for lesson 5, where we have to do balancing equations, right? So I'm just going to make a super short video to make sure we're all on the same page, right? So law of conservation of mass. Basically, it's the mass of the reactants is equal to the mass of the products. It's very key. We did a lab on this where you had baking soda and vinegar, and you took the mass of it before, and then you completed the reaction, and you took the mass of it afterwards. And you should have found that they were pretty close, almost the same, right? So if I gave you a practice problem where it says, given the equation, what is the mass of the reactants if the mass of my products is 200 grams? So everything at the end of the arrow is my product. And in the problem, it says that my product has a mass of 200 grams. Therefore, according to the law of conservation of mass, my reactants should also have 200 grams. So reactants is everything that I start with before the arrow that needs to get mixed in together to become this. It's going to weigh 200 grams. Super simple. So mass before, total mass before, should equal to the total mass after. So let's move on to law of conservation of matter. So law of conservation of matter is almost exactly the same thing. So the number and type of atoms in the reactants is the same as the number and type of atoms in the products, meaning there's no random new atom that you created. So let's go through an example. Does the chemical equation meet the law of conservation of mass? This doesn't make sense. It should say law of conservation of matter. Uh-oh, it's having a panic attack on me. Erase. Matter. All right, so let's look at all of our reactants before. And this time we have to look at every single atom in the reactant side. So here I have the compound SO3. So I have sulfur. And oxygen. There's no subscript for sulfur, meaning I have one sulfur. And 3 oxygens because my subscript is 3. Right? I also have H2O, H2. H is hydrogen. I have the subscript 2, so I have 2 hydrogens total. And I have 1 oxygen here. So actually, if I add up all of my reactants, I have not 3, but 4 oxygens. If I look at my product side, H2SO4, H2. I'm just going to put it directly across from each other so it's easier to compare. So H2, because my subscript is 2, that means I have 2 hydrogens. S has a subscript of 1 because there's no number written as a subscript. O4, oxygen has 4. So in this case, in my reactants and in my products, I have the exact same type of atoms, right? So there's no new type of atoms created. And I have the exact same number of atoms. So I have 1 sulfur in my reactants, 1 sulfur in my product, 4 oxygens in my reactants, 4 oxygens in my products, 2 hydrogens in my reactants, 2 hydrogens in my product. They're exactly the same. It's just that the bonds have rearranged, right? Or the compounds are different. But I have the same number of atoms, same type of atoms. So final answer, yes. It meets the law of conservation of matter. All right, so now that you've gotten this parts, you can move on to the next lesson, lesson 5, balancing equations.